Okay, so we're going to look at working with some of these collections. In order to use certain types of collections, we have to make sure that we're using the system.collections namespace. I'm going to start with array list and list because those are the most similar to arrays, and arrays are probably where you have quite a bit of experience working with. So the difference between array list and list is that one is type safe and the other isn't. So array list is a non-generic, which means it doesn't specify a data type. You can put any types of elements together in a non-generic collection. So it can hold like one element's a string, and then the next element's an integer, and then the next element's an object, and the next element's a date. There's no rules about what you can and can't put into a non-generic collection like array list. So this is sometimes good and sometimes bad, right? The problem occurs, of course, when you're trying to, say you're trying to loop through and print out each object, or you're trying to loop through and perform some action on each object. If all the objects are different types, then you have to do a lot of work to figure out what type of object you're dealing with in order to how you're going to display or how you're going to do what you need to do to each different type of object. So commonly, you would stick with a generic collection, which means that all of the objects have to be the same data type. But you know, for array list specifically, it's just kind of a quick way of storing all different kinds of things. So we can declare a new array list by you know, just calling on its constructor, and then that class contains some useful methods such as add, remove, insert, and remove at. So let's do a little bit of a demonstration here. So let's see. I'm just going to make a method here that happens when the form loads. So I'm going to create an event on the loading of the form, and we'll work with array list here. In order to work with array list, we have to import system.collections. Now you'll notice that by default it gives us the generic collections, but array list is not in there because it's non-generic. So we need using system.collections. Now we can get to array list. So we've got a list of things I had for breakfast. We can use an add method to add some things. Add a few different things to the breakfast list. There we go. Now we've got a list containing 3 strings. Now, because this is an array list, I'm not restricted to just entering strings. So for example, if I wanted to add any other kind of object, you know, it has no problem putting different types of objects together. However, you know, when I come through later and I want to say, well, what did you have for breakfast? It's easy to say, well, I had milk, toast, and eggs. You know, it doesn't necessarily know what to make of this, right? And depending on which object types you have, you know, you might want to be careful when using non-generics. We can remove things. When you call remove, you just specify which one. It'll search the list and find the first match and remove that. So if I say, no, actually I didn't have eggs, then I'll remove it from the list. So now my array list has milk in position 0 and toast in position 1. So we can remove something, or we can remove at a particular position. You can remove a specific object, or you can remove whatever happens to be at a specific position. We can also insert wherever we want. So if I use insert, I can insert something in a particular spot. So as of right now, I only have object 0 in here, which is milk, because I removed eggs, and this would have removed the toast. So I can insert at the beginning before milk by putting in the 0. What? I coded this backwards. The index comes first. There we go. Now it will say cereal in position 0. Milk will get bumped up to position 1. Okay. Now the takeaway here is it's a non-generic. You can insert any kind of object that you want. So here's some similar to that example. Notice how array list and all list structures offer that positional indexing. So similar to an array, you have those indexes where 0 is the first element and 1 and so far. If you insert in a certain position or remove at a certain position, all the other elements will shift to fill in the gaps. And that's different from arrays, right? If you have an array of 10 elements and you remove element 5, the other ones don't shift down into its place. But in this linked list, they do shift down. So we can still access them with the item operator, the square brackets. We can call on count here, which is different from an array. In an array, we use length, but in a list, we use count. And the reason why, usually I do this as a discussion, but the reason why here is because in an array, the length is fixed. No matter how many elements you put in or remove, you know, if you have an array of size 10, even if you only put one element in and the others are all null, it's still 10. But with a list, there's no fixed size. So count just tells you how many actual objects are in there. And you can perform a loop on an array list using for each, just like any other kind of loop. You can do, you know, a do or a while, but be careful with your data types. So here's an example of performing a loop on this guy. You can say for each. Now when we usually perform a for each, we have to specify what type of object we're doing. So these guys are all strings, right? For each string in the list, we can say show that string. And this will sort of be okay for now, but remember that array list is not type safe. So what happens then if I have, you know, in message box.show, I'm trying to insert a new object. You know, along with this list of milk, toast, eggs, and cereal, I also have like a form object in here. And this is allowed, but then when I get to this point, that form won't be able to be converted into a string. I'm going to get an error message when this happens at runtime. There it goes. So you can see it's trying to turn a form into a string. And this is the problem, you know, with using non-generics. Now I can get around it by using var here. But now you can see that it doesn't understand how to show that var in a message box. So these are just some of the problems that you can encounter, you know, when you're doing non-generic collections. Okay, so let's look at the next ones then. What if we want an array list that holds a more complicated object? We can add anything into an array list, So one thing that you could add into an array list is an object called key value pair. A key value pair object is a thing with two properties, the key and the value. What types of things they are is up to you. So T key and T value here, you can specify. Do you want string keys? Do you want integer keys? Do you want double keys? Do you want date keys? And then the value, again, can be anything that you want. But key value pair is type safe. So this allows you to have, you're simulating kind of like a dictionary sort of object. Now, dictionary implicitly uses key value pair, but if you don't want to use dictionary, you want to use array list and remain type neutral, then you can kind of get around that by putting in a key value pair. So that kind of setup translates well to populating a list box, because when you have a list box, we have two separate values in a list box, right? There's the text that the user sees, and then there's the selected value behind that may be different. So if you have a key value pair, and in this case I've said that the keys and the values are both strings, I'm using a course code as a key and then the course name as the value. And you can add that object with its two properties into a list, an array list, or any other type of list as well. So if you have an array list and you want to use it as a source for a list box, then you need to specify three settings for the list box: the data source, the display member, and the value member. So the display member is what you see, and the value is the selected value when you pick it. Now you'll notice here that these are strings that indicate the names of those two properties. So in a key value pair, you have two named properties, key and value. Value is the thing that you see, and in this case, the key we're using for the selected value. So I know it sounds a little bit backwards, but you just got to figure out which one you want to show where. Hash table is similar, but it includes a key. As opposed to a numeric index, you have a string key. So here's an example of how to use a hash table. I will upload to Blackboard a demonstration, like a program that uses all of these and goes through how to use them. We're almost out of time, so I don't want to waste the time by me typing these things into Visual Studio. If you want to play around with them, then like I said, I'll upload that sample project after the class. So here's an example. If you use hash table, or if you use dictionary, or you can use a list of key value pairs, all of those kind of come out the same way. The difference of hash table is that it's not type safe. So all of these examples have string keys, but you can add one that has an integer key, or add one that has like a different type of key, and they can all be together in the same table. So you can mix and match the types. Now in this example, the My Courses hash table has two sub-collections: the collection of keys, which would contain these three guys right here, and that is the keys collection. And then these three over here, that is the values collection. So if you want to just get to the names of the courses, you would say mycourses.values, and that would be one type of list. And then if you just want to get to the course codes, you'd say mycourses.keys, and you could loop over both of those. So in this for each example, it loops just over the keys collection. Now what happens if we want to do something to the objects inside the collection? You cannot modify objects from within a for each loop because it messes with the indexing. This is about non-generic issues and dealing with type safety. So we want to more often use generic collections. Non-generics can be slower because we're converting and unboxing data types every time. So it's better to use typed collections. And when you use a typed collections, you specify a data type. So when you use list, you specify, okay, a list of what? In this case, it's a list of integers. We can use the same types of methods because they all implement that in iList interface. So we've got add, insert, remove, and remove at. We've got the count property. They work the same way as far as how you use it, but behind the scenes, they operate differently. Other things you can do from list: clear, obviously removes everything, and join here. Join isn't a list member; it's a member of the string class. But you can use string.join to take all the elements of a list and stick them together into one big string. We have dictionary as well, which is a type-safe version of hash table, where we can specify what data types we want for the key and for the value. So in this example, my value type is a custom type that I wrote. It's a car object. So somewhere else in my project, I have a car class, and I want to keep all the cars together, but I want to be able to easily find a specific car. So I'm using a string as a key to search. In this example, I'm using a string that represents the vehicle identification number. So the vehicle identification number is part of the car object, but when I add the car to the dictionary, here Honda is the entire car object being stored. But when I want to look up a car, I can look it up using that unique key, that VIN value. Now in this example, when we do a loop over a dictionary, each object in a dictionary is a key value pair. Or you can use for each with var. So the practice assignment that I give at the end of this one, that I hope you're going to take some time to do, along with the Secret Admirer one from before, is I wanted you to try to create an application that keeps track of a shopping list. So you should be able to add new items, remove a specified item, view all of the items. You might say milk, bread, eggs. And then when you buy bread, you can remove bread from your shopping list. Or maybe you have an option to just clear all the items because you went grocery shopping and bought everything. So things to think about. What kind of structure would be best? How do we make sure only valid items are added? You want to write things that that are strings, so you don't want empty entries. You don't want a whole bunch of like weird numbers or objects or anything like that. What happens if you try to remove bread from the list and there is no bread? Will your application break? How can we show the list to the user? What kind of options can we provide to them to manipulate their list? So you can make a little app, that operates like a little grocery list, and that will give you good practice working with lists, adding items, removing items, clearing lists and things like that. So you can spend some time hopefully working on that little practice assignment. And after a few days, I'll put up a solution as well. Okay, so the last little piece of the slides, I'm going to just probably briefly mention it now. We've got a couple more minutes. Working with collections in Windows Forms. We've already seen how the list box uses a collection. We did it when we did our file I/O, where I added every different line reading from the text file into the list box. So I did it one by one there when I had listbox.items. Items is the collection. So If you have a custom collection or you're working some kind of like array list or something and you want to show them all in a list box, rather than going through one at a time and adding them all individually, you can assign your collection as the data source of a drop-down or list box, and then set the display member and value member properties. So I'll scroll back up a bit so that we can see the example of that. Here it is. Nope, that's not it. Here it is, where you set those three properties. So any kind of list or collection, you can specify it as the data source, and then you just have to tell the list box what property you want to display and what property is going to be the value. So that potentially might help you in your lab. The controls collection is a collection that's part of the form. So if you go to form.controls, it will give you a collection of all of the objects on the form. Some objects are containers and some objects are not containers. So things like form, panel, group box, tab control, they could be on a form and they also could have other objects in them. So this is like a nested collection. The type of object is called control collection, but really it's just another iList. So if you've ever seen something like this, which I know you have, if you're staring at Visual Studio right now, it works exactly like this, where a form is a container and it can contain other forms, and each one of those forms is a container that can contain other forms as well. When we see something like this where we have multiple forms open up inside each other, that's called multiple document interface, or MDI. The outer one is set as the parent, and the inner one is set as the child. If you want to create a program like that, you have to make at least two forms. The main form is the one that appears when the program runs, and then inside that you can specify to create a new version of a child form. I wanted to make sure to mention that because it comes up on the future lab. Okay, so we've seen all different kinds of ways that we can use and interact with collections. I have a completed version of all of the code from the slides, and I'll make sure to upload this to Blackboard so that you can test it out and work with it. So all of those examples that we went through on the slides are here in the code, including the little car class that we were working with in that one example. So if you want to practice or play around with some different types of collections, you can use this to do so once I upload it to Blackboard.